Hi, I'm Vincent. I'm a software engineer at Opinum, and today I will cover 3 new features available in Data Hub, which are alarm detection, data loss detection, and statistics on variables. Hello, welcome to this new session of the Opinum Online Event 2020. I'm Vincent Goossens, and I'm a software engineer at Opinum. Today I would like to cover 3 topics, which are the alarms, allowing you to send notifications when the value of one or many data points are outside an expected range of values. The data loss detection that allows you to be notified when a device stops sending data. And the third topic is the possibility to get statistics about a variable. Let's talk about the alarm feature. This is a brand new feature developed in the last month, already available in a production. And the alarm functionality is aimed at triggering notifications, meaning sending email, calling webhooks, storing events in the database, when the value of a data point, of an incoming data point, causes an alarm condition, meaning that the value is, by example, above an expected value. And you can also trigger notification when the alarm condition disappears. So the alarm is based either on the value of the variable, but is also combined to a state machine that handles the current state of the alarm. So how is the alarm feature implemented? We try to get the value of the incoming data points at the very early stage in the data pipeline. So as soon as you push data or you upload a file, let's say on the FTP server, we will manage all the data points in there, and we will compare the value of the data points against the alarm threshold definition. As I already said, the trigger notification is driven by a state machine that will, by example, prevent to send multiple notifications if multiple data points have a value above the unexpected value. There will be only one notification in that case. We also provide an API that allows you either to create or to manage alarm, create, delete, update, and to query the occurrences of the alarms over a period of time. Maybe you already know that there is an alert feature existing since many times in Data Hub. Why do we come with a new feature called alarm? Because many customers, they were complaining about the fact that the alert suffer from some unexpected behavior that were there by design, but that were very annoying to manage a real alarm environment. So let's compare both feature and highlight the main difference between them. So both feature, either the alarm and the alerts, they are tied to the value of the incoming data point. In an alert, you can only define a single threshold value, while for an alarm, you may define a single value or 2 values, meaning that you will define a hysteresis, causing the alarm to be triggered when the data point value goes above the high level threshold, and the alarm will disappear when the data point value goes below the low level of the threshold value. It avoids to send multiple notifications when the signal is around the abnormal value. The alert doesn't have any state. The alarm has a state. The state machine, we will see a little bit later, combines multiple state in the sense of it combines the value of the data point itself and the fact that, by example, the alarm was acknowledged by the user or not. Both features, they allow multiple notifications, so you can decide to send an email and to store an event in the Data Hub database. You know that events can be shown in dashboards. Both have an history, and as already said, the alert feature will trigger the notification every time the value of the data point is outside the expected range of data, which was the main annoying behavior of this feature. In the alarm feature, since the notification triggering is controlled by a state machine, you will get only one notification, even if there are multiple data points coming into the database and having a value that is outside the expected range. The alert feature has no acknowledgement feature, which was implemented in the alarm feature. It's just an internal state that you can manage, but it allows you to create a real alarm dashboard, knowing when, by example, when the alarm was triggered, when and or if it was acknowledged, and by whom it was acknowledged. The alert feature does not allow any data hub variable to follow the alert state, which is the case for the alarm. You can tie another variable to the alarm state. This variable will be a value of 1 if the alarm is present, or 0 if the alarm is not present. As I said, there are states in the alarm feature, and here are the various states that can qualify a single instance of an alarm. First state is uncertain. When you when you just create an alarm, you don't know the real state of the alarm until the first data point enters the database. That's why at this stage the alarm state will be uncertain. An alarm can be present or not present, meaning that the last data point that entered the database was above or below, above for present, below for not present, the threshold value. NAC is an acknowledgement indication, which is an internal state that we maintain, but that is driven by the user through the API. So you can mix, the states can be mixed between present, not present, and acknowledged, not acknowledged. So meaning that you can have an alarm that is present, but that is not yet, or that will never be acknowledged, and that is stored in the database in the alarm occurrence. The last state is inhibited, so you have a way through the API to disable the alarm feature for any reason, just because you don't want to get any notification anymore. Here is the state machine of the alarm state. So keep in mind that every transition from one state to the other will be stored as an occurrence in the database. So not only the fact that the alarm is present or become present or not will be stored, but every change from present not acknowledged, by example, to present acknowledged, that will be stored in the database. So you have the full history of the alarm that you can query again through the API. This ends the alarm topic. Let's go to the next one. The second topic of this session is the data loss detection feature. And this feature allows you to detect that there are consecutive events missing from a signal. I use the term signal, although the title of the topic is called data loss detection, because we plan to apply this feature not only to incoming data points, but also to file uploads or calculated variable triggering. But at the time being, only the data points can be used to detect the data loss. So the data loss detection is just like alarms, implemented at the very early stage of the data point stream. And in this case, we don't care about the value of the data points. We just care about the fact that the data points are incoming in an expected period. The data loss detection, it maintains a data variable in the database that reflects the fact that we have detected a data loss or not. So when you define data loss detection on a variable, the engine data hub automatically creates a new variable that will be a binary variable, which is 1 if the engine detects a loss of data, meaning some event that didn't come in the expected period, and that will be 0 if everything is okay. You can manage, of course, all the data loss detection feature through the API, meaning that you can create, delete, modify data loss, and you may have query some of the internal values maintained by the data loss detection feature, which is mainly the period of the signal that we will cover in the next slide. The documentation is available on our documentation sites, docs.opinum.com. So, how does this feature work? There are two important notions. The first one is the average period of the signal. So, the purpose of the data loss detection is that to detect that in a given period of time there is no data point that entered the database. So this period is determined by a factor applied to the period of the signal, but we don't use the period that is declared in the variable itself. We will compute the period on the fly. So in this diagram, you see that we have a bunch of incoming data points, and we will compute the average period based on the last 100 data points received. So we know that the average period between every data point is P. Let's call it P. The second important parameter is the missing signal factor, which is a factor that you will define when you create a data loss detection, and that will say if we have a period of time bigger than the missing signal factor times the average period, which is here, we must consider that the signal is lost. So most of the time, we recommend to use. It really depends on the behavior of the input signal. But if it's an input signal reflecting data coming from a device, we recommend to use a signal factor of 3 or 4, meaning that you can lose or miss 3 or 4 data points before declaring that the signal is lost. When the signal is lost, the output variable that is automatically created in DataUp will be set to 1. Like we see here, the output variable. So the state is now missing, but the data points of the output variable will not be the time at which we notice the data lost, but it will be the timestamp of the last data point just before the period. The state keeps on being missing until we get a new data point, which sets the output variable to 0, sets the timestamp of this output variable to the one of the first data point that moved the state out of missing, so transition from missing to OK, and we restart the computation of the average period. There is also a situation where we cannot trust the average period anymore, and this happens when the device is disconnected for a very long, abnormally long period of time. So you will also define an abnormal signal factor that will tell if we don't get any data point during a period equal to the abnormal signal factor times the average period, we will completely forget any data that allows to compute the average period. And we will restart just if the detection, the data loss detection, was set up for the first time. This allows you to get you and us to have a better evaluation of the period, especially if you change the sampling time in your device. If we don't reset the internal count to use and the value to use the average period, it could take quite a long time to adapt, because remember that we use the last 100 data points to calculate the average period. So you will tell the data loss detection engine that after a given period of time, we must restart the computation of the average period. Of course, having a single variable set to 1 in DataUp is fine, but it's very handy to combine this data loss detection feature with the previous topic that we have seen, which is the alarm. So if you want to create an alarm to trigger a notification when a data loss is detected, you just create an alarm. First of all, of course, create a data loss detection on a given variable. You create an alarm on this created variable in Data Hub, and you define the notifications. So once the data loss is detected, Data Hub will set the data loss output variable to 1. This will trigger the alarm notification, allowing you to get notified that you have some communication issue, or at least that you lost some data points. This ends this topic of the data loss detection, and let's have a look at the way we can get statistics about, by example, the number of data loss that we had in a given period of time. The last topic in this session is the ability to get statistical information on variables. Are you interested knowing how many times the temperature was above 25 degrees? How many times you faced data loss detection? Then the statistics on variables is there for you. So it just computes statistics on the value of a variable over a given period of time. So the query statistics is available through the API. You just specify the ID of the variable, the period, and you get the statistics based on the value given a threshold that you want to compare all the value against. The documentation is available in our documentation center at docs.opinum.com. This feature applies to both analog and binary variables. You will get the same result, but some of the results are meaningful for analog variable or binary variable. If you use, by example, if you get the statistics on the analog variable, you will get information about the number of samples, also called data points, above or below the threshold, the average time below the threshold, the min, max value, the number of sample, and stuff like that. On binary value, you will get, by example, the number of rising and falling edges on this variable, the average time that the binary value was 1 or 0, the number of sample that are in the requested period. You can also not only have one statistic result set over a single period of time, but you can also group them by day, month, of year, or year, meaning that you could know, by example, how many data loss detection you faced during 1 month, grouped by day. Thank you all for attending this session. I hope that you will enjoy these new features. If you have any question or remark, please feel free to reach us at www.opinum.com/contact.